cosmic dust is not simply something to sweep under the rug and forget about. Instead, NSF-funded astronomers are studying and even mapping it to learn more about what it might be hiding from us, where it comes from and what it's turning into. Some researchers are delving deep down to see how dust comes together at the atomic level, while others are looking at the big picture to see where stars and planets might be forming in dusty stellar nurseries. Recent discoveries, such as that of a very young galaxy containing much more dust than expected, have shown us that we still have much to learn about where exactly all this dust comes from. A little bit of dust makes a very large problem. Although dust only makes up about 1% of the interstellar medium, the stuff between the stars, it can have big effects in astronomical observations. Dust has a bad reputation because it gets in the way by absorbing and scattering the visible light from objects such as far-off galaxies and stars, making them difficult or impossible to observe with optical telescopes. The scattering effect dust has is known as reddening. Dust scatters the blue light coming from an object, making it appear redder. This occurs because dust has a greater effect on light with short wavelengths, such as blue. A similar effect is what causes sunsets to appear red. Astronomers can tell a lot about a star simply by its color, so this reddening effect can trick us into thinking a star is cooler and dimmer than it actually is. However, thanks to NSF-funded astronomers like Doug Finkbeiner of the Harvard-Smithsonian Center for Astrophysics, we can now correct for dust reddening and recover a star's intrinsic color. Finkbeiner first began studying cosmic dust as a graduate student at the University of California, Berkeley in the late 1990s. Dust may seem like an odd thing to dedicate an astronomical career to, but dust is not as obscure as it sounds, Finkbeiner said. Objects like the Orion Nebula, the Horsehead Nebula, and the Pillars of Creation are dense, dusty clouds intermingled with bright stars, making a beautiful scene. But every part of the sky has at least some dust, and even a tiny amount of dust can interfere with astronomical measurements, so we need a way to correct for it.